Hey guys, I'm going to teach you how to write equations with variables on both sides. By the end of this lesson, you'll be able to model and solve real-world situations with equations that have variables on both sides. So go ahead and get out your binder, turn to the math section, let's go ahead and take some notes. Let's start off by reviewing the different ways we can state these mathematical operations. So before I tell you them, let's go ahead and try to list as many synonyms you can, or clue words that might tell you to add, subtract, multiply, divide, or equals. Now take a minute and jot down all of these keywords that you may have missed. It's important to know these keywords because when you read word problems, they might not tell you explicitly what type of operation to do. Instead, you're going to have to figure out what kind of operation is happening. I do that by reading the problem and then as I read, underlining any numbers and then the keywords that are around them. Here's our first example. Underline along with me. It says Hudson and Knox are in a race. Hudson is running at a speed of 8.8 feet per second. Knox got a 30-foot head start and is running at a speed of 6.3 feet per second. How many seconds will it take until Hudson and Knox are at the same place? So I know that there are two people in the race, Hudson and Knox, but what do I need to know to get the answer to this problem? We need to know how many seconds it'll take for them to be at the same place. In a word problem, it's usually the last sentence and it's what the question is asking for. Since the number of seconds is unknown, let's use a variable, which is what we use to represent an unknown number. In this case, I'll use x. Now we can start writing expressions or equations for Hudson and Knox given what we know from the problem. It says Hudson can do 8.8 feet per second. Per is a keyword for multiplication. So when we write the equation or expression for Hudson, we would want to write 8.8. We don't have to write feet. Per means times, and we don't know the number of seconds. So we can write 8.8x. Knox has the same thing with the feet per second, but he has something extra in his. He starts at 30. So let's go ahead and start by writing 30. Then you see the word and. And is a clue word for one of these operations. Can you guess which operation and is a clue word for? And is a clue word for addition. It lets you know that there's something plus something else. So Hudson got his 30-foot head start, and we'll write plus. He does 6.3 feet per second. How do we write 6.3 feet per second? I would write it just like we did Hudson's. 6.3 times the number of seconds. So I have the expression for Hudson, I have the expression for Knox, and I have one more key word I haven't used yet. Same. What does the keyword same tell me? Same means equals. Since I want to know when Hudson and Knox are the same, I'm going to set their expressions equal to each other. This is the equation I'm going to use to solve for x. We'll do that just like any other equation with a variable on both sides. Get your x's over to one side, your numbers to the other, and then go ahead and tell me what is the solution to this equation. You should have got x equals 12, but a lot of the times with these word problems, the question will say, what does your answer mean in the context of this problem? Basically, that just means, what does your 12 mean? Since we needed to know how many seconds, and we just solved and got 12, the answer is that it will take 12 seconds until Hudson and Knox are at the same place. All right, every one of these problems is going to be done just like that, so we're going to do number 2 together. As I read, underline or circle any keywords and numbers you need to solve the problem. Celebrity A has 400 followers on social media and is gaining 75 followers each day. Celebrity B has 1,000 followers on social media but is losing 25 followers a day. How many days will it take them to have the same number of followers? We should have underlined these keywords and numbers because we'll be using them to set up our equation. Starting with Celebrity A. Celebrity A has 400 followers. And is a keyword for addition. Gaining is another keyword for addition. 75 followers each day. Each is a keyword for multiplication. And since I don't know how many days, I'm going to use the variable x. So this is the expression for Celebrity A. You try to write the expression for Celebrity B. For Celebrity B, they have 1,000, but they're losing 25 followers each day. If something is a loss or a decrease or getting fewer, that's a subtraction sign. And then since we want to know when they'll have the same number, we need to do our last step, put an equal sign between them. Now we can solve our equation. We'll get our x's on one side, our numbers to the other, and then go ahead and finish this out. Tell me what is the solution to the equation and what does it mean in the context of the problem. you should get x equals 6, which means it'll take 6 days for these two celebrities to have the same number of followers. Let's do the same thing for number 3. As I read, make sure to underline or circle any numbers or keywords in the problem. Ben and his friends are going to play putt-putt. At one location, they can pay $2 for rentals plus $7.50 per game. At another location, it would cost $8 for rentals plus $6 per game. How many games would they have to play in order for either location to cost the same amount? Hopefully you realize that these were the important numbers and keywords that you're going to use to set up your expressions and write your equation to model this situation. I'll do the first one in yellow with you. Here's the situation. You go to the first location and you got to pay $2 just to get your equipment to play putt-putt. Plus, you got to pay for each game, and each game is $7.50 per game, and we don't know how many games we want to play. Your $7.50 X. X can be the number of games. The second place is just like that. So take a second and write your expression for the second location. At the other place, it's a little more expensive for the rentals, but it's cheaper for the cost of the game. So what we need to find out for Ben and his friends is after how many games would they have to play for these to be the same? Same means equals. So put your equals between these two expressions and then solve. Go ahead and do that now and press play when you're ready to check. All right, check your work. You should have got x equals 4. What does 4 mean in the context of this problem? 4 is the number of games Ben and his friends would have to play for it to cost the same at either location. Those two problems were very similar, but number 4 is a little bit different. We're going to read about Haley and Hank. They're a brother and sister who have different information, but sometimes it's written in the same line. So be very careful about what you write down about Haley and what you write down about Hank. I'm going to do this in 2 different colors. To start with, it says Haley has $155 in savings. Her brother Hank has $230. Haley is saving $10 each week, and her brother is spending $15 each week. After how many weeks will their savings accounts have the same amount of money in them? This is wrong. Do not write this down. But this is a mistake I see people make a lot of the time. We don't want to do this. Instead, what we want to do is make sure that we're writing about Haley separate from Hank. So let's start with that. Haley has $155, and she's saving $10 each week. And we don't know the number of weeks, so I'm going to write X. Now you can write the equation for Hank. All right, is this correct, or did I make another mistake? Hopefully you caught the difference between Haley and Hank. Haley is saving money. Hank is spending money. If you're spending money, we're going to represent that with a minus or a subtraction sign. Then we want to know when they'll have the same amount. So put an equals and then solve. You should have got x equals 3. What does the 3 mean in the context of this problem? It'll take 3 weeks for these two siblings to have the same amount in their savings accounts. All right, for number 5, I'm going to read it and you're going to try to write the equation all by yourself. It says Isabel takes the bus to work. The bus ride to work costs her $2.50 each time. She could buy a bus pass for a one-time fee of $15 and would then only pay $1 each time to ride the bus. How many times would she have to take the bus in order for the cost to be the same? Isabel's first option is in purple. It's $2.50 per time, so X is the number of times. And the other option has a one-time fee of $15 and it's $1 per ride. Since we want to know when those costs will be the same, we're going to put an equals between them. Now we'll solve this equation. We'll get our x's on one side, so subtract the 1x from both. Then last step, divide by that $1.50 from both sides. What does your answer and what does it mean in the context of the problem? You should have got 10, which means it'll take 10 times to take the bus in order for the cost to be the same. All right, number 6 is a challenge problem. It says 2 more than 16 times a number is the same as 21 less than the product of -7 and the number. Since the number is unknown, we'll use the variable x anytime the problem says a number. If you want to try this challenge, pull out that keyword clue sheet and then try this as much as you can by yourself. Press play when you're ready to check. I would start with 16 times the number, 16x, and it's 2 more than that, so we're going to plus 2. Is and same means equals, and it says 21 less than the product of -7 and the number. Product means times. So I'd write negative 7x, and it says it's 21 less than that. So we would write minus 21. It does matter the order you write that. The 21 does have to go behind that because it says it's 21 less than this. Now you can solve your equation for x. In this situation, the mystery number was negative 1. Number 7 is very similar. It's another challenge. So see if you can try it all by yourself and then press play when you're ready to check. This is the equation we should have used, and your solution should be 1/2 or 0.5. And that's it. Thank you for watching. If you have any questions, please let me know. Bye.